Welcome to our exploration of solubility and solutions. In this video, we'll break down what solubility means, why it matters, and how it impacts everyday life. From the sugar dissolving in your morning coffee to the salt in ocean water, solubility is all around us. Understanding this concept helps us grasp how substances interact and mix, forming solutions that are vital in science, industry, and even cooking. Let's start by defining the basics and setting the stage for a deeper dive into the fascinating world of solutions. Solubility is the ability of a substance, called the solute, to dissolve in another substance known as the solvent. When a solute dissolves, it forms a homogeneous mixture called a solution. The extent to which a solute dissolves depends on several factors, including temperature, pressure, and the nature of both the solute and solvent. For example, sugar dissolves easily in water, but sand does not. This difference is due to the chemical properties of the substances involved. Let's look at how these interactions work in more detail. Solution is a special type of mixture where one substance is completely dissolved in another. The solute is the substance being dissolved, while the solvent is the substance doing the dissolving. In most cases, the solvent is present in a larger amount. For example, in salt water, salt is the solute and water is the solvent. Solutions can be solid, liquid, or gas, depending on the substances involved. Understanding solutions is key to many scientific processes and everyday phenomena. Solutions come in many forms. The most common are solid and liquid, like sugar and water, but there are also gas and liquid solutions, such as carbon dioxide and soda, and even solid and solid solutions, like alloys. Each type of solution has unique properties and uses. By understanding the different types, we can better appreciate the diversity of mixtures that exist in nature and technology. Solubility curve is a graph that shows how the solubility of a substance changes with temperature. Typically, as temperature increases, most solids become more soluble in liquids. However, gases often become less soluble as temperature rises. These curves help chemists predict how much of a substance will dissolve under different conditions, which is crucial for many industrial and laboratory processes. Several factors influence how well a solute dissolves in a solvent. Temperature is a major factor, as higher temperatures usually increase solubility for solids and liquids. Pressure mainly affects the solubility of gases, with higher pressure increasing gas solubility in liquids. The chemical nature of both solute and solvent also plays a role. Polar substances dissolve best in polar solvents, and nonpolar in nonpolar. Understanding these factors helps us control and optimize solution formation. Let's focus on temperature. When you heat water, sugar dissolves faster and more completely. This is because increased temperature gives molecules more energy to move and interact, breaking apart the solute and allowing it to mix with the solvent. However, for gases, higher temperatures usually mean lower solubility, as gas molecules escape more easily from the liquid. This is why warm soda loses its fizz quickly. Pressure has a significant effect on the solubility of gases and liquids. Increasing the pressure above a liquid forces more gas molecules into solution. This principle is used in carbonated beverages, where carbon dioxide is dissolved under high pressure. When you open the bottle, the pressure drops and the gas escapes, forming bubbles. This relationship is described by Henry's law, which states that the solubility of a gas is directly proportional to the pressure above the liquid. Chemical nature of both the solute and the solvent determines whether a substance will dissolve. Polar solvents like water dissolve polar solutes such as salt or sugar. Nonpolar solvents like oil dissolve nonpolar substances such as grease. This is often summarized as like dissolves like. Understanding this concept helps explain why some stains are removed with water, while others require special solvent. Saturated solution is one in which no more solute can dissolve at a given temperature and pressure. Any additional solute will remain undissolved. This point is important in many chemical processes, as it marks the maximum concentration of solute that can be achieved. For example, when making rock candy, sugar is dissolved in water until the solution becomes saturated, and then crystals begin to form as the solution cools. Unsaturated solution can still dissolve more solute, while a supersaturated solution contains more solute than would normally dissolve at that temperature. Supersaturated solutions are unstable and can quickly crystallize if disturbed. This property is used in making certain candies and in chemical demonstrations. Understanding these terms helps us control solution properties in both science and industry. Solubility and solutions are part of daily life. When you stir sugar into tea, dissolve instant coffee, or add salt to pasta water, you're creating solutions. Even cleaning products rely on solubility to remove stains and dirt. Understanding these everyday examples helps us see the practical importance of solubility in our routines. Nature is full of solutions. Oceans are massive saltwater solutions, and rainwater dissolves minerals as it flows through soil and rocks. Plants absorb nutrients dissolved in water, and animals rely on dissolved gases like oxygen in water to survive. Solubility is essential for life and the environment. Industries use solubility principles in countless ways. Pharmaceuticals rely on solubility to deliver medicines effectively. The food industry uses solutions to create flavors and preserve products. Even mining and metal extraction depend on dissolving minerals from ores. Mastering solubility is key to innovation and efficiency in many fields. In medicine, solubility determines how drugs are absorbed and transported in the body. Some medicines must be dissolved in water to be effective, while others require oils or other solvents. Scientists design drug formulations to optimize solubility, ensuring that patients receive the right dose in the right form. Food and beverage industry uses solutions to create everything from soft drinks to soups. Flavors, colors, and preservatives are often dissolved in water or other solvents to ensure even distribution and stability. Understanding solubility helps manufacturers produce consistent, high-quality products. Solubility affects the environment in many ways. Pollutants dissolve in water and can travel long distances, impacting ecosystems. Understanding how substances dissolve helps scientists predict and manage pollution, ensuring cleaner water and healthier habitats for plants and animals. Cleaning relies on solubility. Soaps and detergents dissolve grease and dirt, allowing them to be rinsed away with water. Some stains require special solvents because they don't dissolve in water. Knowing which substances dissolve in which solvents makes cleaning more effective and efficient. Cooking is full of examples of solubility. When you dissolve sugar in water for syrup or salt in soup, you're creating solutions that enhance flavor and texture. Understanding how ingredients dissolve helps cooks achieve the perfect taste and consistency in their dishes. Weather phenomena are influenced by solubility. For example, clouds form when water vapor dissolves in air and then condenses. Rainwater dissolves gases and minerals as it falls, affecting soil and water chemistry. Understanding these processes helps meteorologists predict weather and environmental changes. Water treatment plants use solubility principles to remove contaminants. Chemicals are added to dissolve or precipitate unwanted substances, making water safe to drink. Understanding solubility helps engineers design effective treatment processes that protect public health. Farmers rely on solubility to deliver nutrients to plants. Fertilizers dissolve in water, allowing roots to absorb essential minerals. Understanding which nutrients are soluble helps optimize crop growth and yields, supporting food production worldwide. Mining operations use solubility to extract valuable minerals from ores. Chemicals are added to dissolve specific metals, which are then separated and purified. This process, called leaching, is essential for producing metals like gold and copper. Artists use solubility in painting and dyeing. Paints and inks are solutions or suspensions, and their solubility affects how colors mix and adhere to surfaces. Understanding solubility helps artists achieve desired effects and preserve their work. Technology relies on solubility in many ways. Electronics manufacturing uses solutions to clean and etch components. Batteries depend on soluble chemicals to store and release energy. Understanding solubility enables innovation in high-tech industries. Cosmetic products, from lotions to shampoos, are carefully formulated solutions. Ingredients must dissolve properly to ensure safety, effectiveness, and pleasant texture. Understanding solubility helps cosmetic chemists create products that meet consumer needs. Energy production often involves solutions. For example, power plants use water to dissolve chemicals that control corrosion and scaling. Fuel cells rely on soluble electrolytes to generate electricity. Understanding solubility is key to efficient and sustainable energy systems. Scientific research often depends on solutions. Chemists prepare solutions to carry out reactions, analyze substances, and study properties. Accurate measurements and understanding of solubility are essential for reliable results in the lab. Safety in handling chemicals often depends on solubility. Some substances are safer to handle when dissolved, while others become more hazardous. Understanding solubility helps workers and scientists manage risks and prevent accidents. Waste management uses solubility to treat and dispose of hazardous materials. Chemicals are dissolved, neutralized, or precipitated to make waste safer for disposal. Understanding solubility helps protect the environment and public health. Textile manufacturing uses solutions to dye fabrics and treat fibers. The solubility of dyes in chemicals affects color quality and fabric performance. Mastering solubility ensures vibrant, long-lasting textiles. Construction materials often involve solutions. Concrete and mortar are mixtures where solubility affects setting and strength. Additives are dissolved to improve durability and performance. Understanding solubility helps engineers build safer, longer-lasting structures. Transportation systems use solutions for maintenance and operation. Antifreeze is a solution that prevents engines from freezing, and de-icing solutions keep roads safe in winter. Understanding solubility ensures reliable and safe travel. Electronics manufacturing uses solutions to clean, etch, and assemble components. Solubility affects how materials interact and ensures the quality of electronic devices. Mastery of solubility is crucial for producing reliable, high-performance electronics. The plastics industry uses solutions to create and process polymers. Solvents dissolve raw materials, allowing them to be shaped and molded. Understanding solubility ensures the production of strong, flexible plastics for countless applications. Paper manufacturing involves dissolving wood pulp and chemicals to create smooth, strong sheets. The solubility of additives affects paper quality, printability, and durability. Understanding solubility helps produce high-quality paper products. Paints are solutions or suspensions of pigments in solvents. The solubility of pigments and binders affects color, drying time, and finish. Understanding solubility ensures beautiful, long-lasting paint jobs in art and construction. Cleaning products are carefully formulated solutions. The solubility of active ingredients determines how well they remove dirt, kill germs, and leave surfaces spotless. Understanding solubility helps manufacturers create effective, safe cleaning solutions. Beverages like tea, coffee, and soft drinks are solutions. The solubility of flavors, sugars, and gases affects taste, texture, and enjoyment. Understanding solubility helps beverage makers craft delicious, refreshing drinks. Pharmaceutical companies design drugs with solubility in mind. The right solubility ensures that medicines dissolve properly in the body, providing effective treatment. Research into solubility leads to better, safer medications for patients. Cosmetic chemists use solubility to create lotions, creams, and makeup. Ingredients must dissolve and mix well to provide smooth application and lasting effects. Understanding solubility ensures high-quality, safe cosmetic products. Environmental scientists study solubility to track pollutants and nutrients in water, soil, and air. Understanding how substances dissolve and move helps protect ecosystems and human health. Solubility research supports conservation and pollution prevention. Innovators use solubility to develop new products and technologies. From advanced materials to sustainable solutions, understanding how substances dissolve opens doors to creativity and progress. Solubility is a foundation for scientific and technological breakthroughs. Solubility is part of our daily routines, from making drinks to cleaning, cooking, and even enjoying art. Recognizing the role of solutions helps us appreciate the science behind ordinary activities and make better choices in products and processes. Summary: solubility and solutions are fundamental concepts that impact science, industry, and everyday life. By understanding how substances dissolve and interact, we can solve problems, create new products, and improve our world. Whether in the lab, the kitchen, or the environment, solubility is a key to unlocking the mysteries of matter. Thanks for joining us on this journey through the world of solubility and solution.